problem 7-15 in section 7.1.2 homework. It says copy the triangles at the right. Label the missing sides with their exact lengths, that is, leave your answer in radical form. So we're not going to have any decimals in our answer, if necessary. So these triangles you kind of learned last year in geometry, or you should remember them, and there were a special relationship between all the angles and then therefore all the sides. So we know across from the 90, or the 30 degree angle, is a 1 that is given to us. That's side 1. The next larger angle is the 60 degree angle. And across from that, if you remember from last year, is the second largest side, which is the square root of 3 in this case. Across from the largest angle, which is a 90 degree angle, this should be my hypotenuse, and this is going to be a 2. So these are the same as last year. You should remember them, hopefully. 30, 60, 90 relationship. And if you looked at the math notes in today's lesson, the numbers were different than these, and that's because they were having the radius or the hypotenuse of the triangle to be a 1 rather than a 2. So that is kind of easier if you need to change it for larger scaled triangles, but for this case it's okay if our hypotenuse is worth 2. So now I'm going to look at the other triangle, 45, 45, 90. Across from the 45 is a 1, and since I also have the same angle of 45 here, across from this 45 will also be a 1. Now if you remember from last year, across from the 90 in 45, 45, 90 will be a radical 2. Now if you don't remember how to these values, at least for the 45, 40, 90, you can use the Pythagorean theorem quickly to remember the other side. So I have 1 squared plus the other side 1 squared equals my hypotenuse squared. So 1 squared plus 1 squared would give me a 2, which equals hypotenuse squared. Take the square root of both sides, and that is how we get that radical 2. So C equals radical 2. So if you're not sure how to get the third side, that's how we could do so. Now part B of the problem says a 30, 60, 90 triangle is sometimes called a half equilateral, meaning half equilateral triangle. Draw a picture to illustrate this and explain how that fact can be used to help label the missing sides in part A. So say we didn't know those sides, we can use the fact that it's half of an equilateral triangle to help us. Now an equilateral triangle should have the same sides and the same degrees. So all these should be the same measurement. Now we know a triangle adds up to 180 degrees, so each of these should be a 60 if they need to all be equal. Okay. Now it wants us to use our 30, 60, 90 triangle to be a half of an equilateral. So I'm going to cut this in half. Now my 60 degrees is also cut in half, so this becomes 30 degrees up here. Okay? And we know this is going to be a 90. It's straight down. So what we knew from before, what was given to us in the problem, in your text, said across from the angle 30 degree angle was a 1. Right? So across from my 30, I know this is a 1. Now this is also 30 degrees right here, because we cut the 60 in half, so across from here is also a 1. So now we have our entire length of the triangle is really worth 2. So now this is really 2 right here. And since they're all the same, this is a 2, and this is a 2. Okay, so now I know all the sides are worth 2 if it was an equilateral triangle. So what we need to do is use this information to help us actually figure out the values of that triangle. So I'm going to copy just the left-hand side of this. I'm going to copy just half of the equilateral. We knew this was 30. We know this is 60. And we said half this down here, and the problem was given to us that it's a 1. From using our equilateral triangle, we know the hypotenuse side was a 2. Now what we don't know is what the height of the triangle is, right here. But we can do this again with the Pythagorean theorem. I have 1 squared plus my side b squared equals a hypotenuse squared. So 1 plus b squared equals 4. Subtract the 1 over, I have b squared equals 3. And I take the square root of both sides to cancel out the squaring. So b equals the square root of 3. So that's how I can prove those values for the triangle, being if half of an equilateral triangle is the 30, 60, 90.